All right, in 7-6, we're working with rational exponents. And a rational number, remember, is a fraction, or a number that can be written as a fraction. So when exponents are fractions, how we handle that is this. B to the 1 over n is the same as the nth root of b. So if you have b to the 1/4 power, it means what's the 4th root of b? Same thing. The discussion in the box says if you have a negative number as your base, which would end up being under your radical, and if you're trying to take an even root, then you're going to get a complex number. For example, the example they show here. If you're trying to take negative 16 to the 1/2 power, which means the square root of negative 16, remember if it's square root, you usually don't put a little 2 there, you're going to end up with 4i. Because there is no number times itself an even number of times that gives you a negative number. Okay. There's actually another box in the lesson. I wonder if, I don't think I cut it out and I really want to talk about it. So I'm going to insert some notes here. Rational exponents like this. If you have a base and it's raised to an x over y power, now think of it this way. It's the same as b to the 1 over y power, which we just learned in the last screen, raised to the x power, right? Because when you raise a power to a power, what you're doing is multiplying. When you multiply 1 over y times x, or x over 1, don't you get x over y, which is what we have over here? So raising b to the 1 over y power and then taking that and raising it to the x power would be the same as taking b raising to the x over y power. So what that means is, remember what b to the 1 over y power means? It means you're taking the y root of b, and then you're raising it to the x power. So basically, every time you see b to the x over y, it means the y-th root of, well, that's a b, of b to the x power. Now, if it makes it easier to compute, it is the same as raising b to the x power and then taking the y-th root. It doesn't matter which order you do it in. So the way I think of it is that this number is higher, this x, and that's the one that you're raising to a power. You're raising it to the x power, and y is underneath. It's like underneath the ground, so it's the root. So they show a really good example is negative 16 to the 3/2 power. What if you saw that? Like, wow, what does that mean? It's the square root of negative 16 and then raised to the 3rd power. So let's talk about that. Do we know how to do the square root of negative 16? Hopefully you know it's 4i. And then you're going to take that and raise it to the 3rd power. Now what that means is 4 times 4 times 4, which is 64, times I times I times I, which is I to the 3rd. That's not a simplified answer. Remember that since I squared is equal to what? Negative 1. This is really 64 times I squared times I. Therefore, it's 64 times negative 1 times I. So you get negative 64I. So it wouldn't be proper to leave an I squared or an I cubed or I to any other power other than 1 in your final answer. All right, let's go ahead and look at this box. We always have to have all our answers in simplified form. So what we have to remember is we have no negative exponents in our final answers. And we have no exponents that are not positive integers in the denominator. Okay, no exponents that are not positive integers in the denominator. Well, wait a minute. Don't we never have negative exponents? Anyway, I'm not sure why they listed that one. It's not a complex fraction. So you can't have a fraction in a fraction ever for final answer. And the index of any remaining radicals is the least possible. Let me show you what that means. You can't have something like the fourth root of x squared because that's really x to the 2/4 power. Well, you know better than to ever say something like 2/4 in a final answer. So that would be the same as x to the 1/2 power, which would be an acceptable answer, or the square root of x. You would not leave it in this form or this form. All right, let's do a ton of examples. They ask us to simply start slow by writing x to the 1/6 in radical form. They're just saying, using a radical, how do I write that? I put a small 6 in here to show the 6th root of x. Going the other direction, part B, they want you to write the 4th root of z in exponential form. So that's z to the 1/4 power. All right, try 1A. And then 1B, 1C, 1D. You could pause while I do it. This one's going to be the 5th root of A. This one's going to be the c to the 1/8 power. This one is d, the 4th root, and then raised to the 7th power. If you wrote it like this, with the 7 inside the radical, that's the same. This is c to the -5th, raised to the 1/3, which is c to the, now remember, -5/1 times 1/3 is really -5/3. So that's a -5/3 exponent. And remember, you never leave your, well, actually they left it in this form for this answer, but I don't like how they do that because it's going to give you mixed messages. You never leave a negative exponent. So what it means is, since this is implied to be over 1, you make it 1/c to the positive 5/3. Remember, a negative exponent just means move it to the other side of the fraction bar and change it to a positive exponent. Now we want to actually evaluate this, and you should be able to do all these without a calculator. So it's kind of an awkward thing because I want you to be able to do it without a calculator, but some of them you might need a calculator to actually do. So let's talk about this. If this is 81 to the -1/4 power, which is over 1, I'm going to first take care of the fact that the exponent is negative. So I'm going to move it to the other side of the fraction bar and change it to a positive exponent. Next, I'm going to say, well, I'm going to change it to radical form. This is really the 4th root of 81. I'm going to ask myself, because I think we're smart enough to do this, what number times itself 4 times gives us 81? Remember, we're doing this in our heads so that we feel the understanding of what the 4th root is. We have to really make sure we get it. So the 4th root of 81 is 3. This ends up being 1/3. All right, how about 216 to the 2/3? Remember, it means 216, the 3rd root, raised to the 2nd power. So, first of all, you might be thinking, how can I do the cube root of 216? Well, it's honestly a kind of a common one. So think of numbers. What times itself 3 times gives you 216? If you happen to think about it, it's actually 6. because 6 times 6 is 36. And then if I multiply by another 6, 18, 19, 20, 21, I get 216. So this part is equal to 6. But then we're going to square it. So this whole answer is 36. Oh, they did it an interesting way. Well, I don't think it's any easier. They said, if you know that 216 is 6 to the third power, you're raising it to the second power. This is not actually exactly what they did. The 3 and the 3 here always cancel. If you're taking the cube root and you are cubing something, it's doing opposite things. Okay, try this one. This one's something people get wrong because they're really not careful. You've got to be sure of your understanding of the properties. So, remember, this is over 1. And since it's a negative exponent, I put it on the bottom with the negative sign. But I changed the exponent now to positive. So this is saying 1 over the 5th root of negative 3125. Now, can I take a 5th root of a negative number? Yes, because a negative times a negative times a negative times a negative times a negative is negative, because I'm multiplying it to itself an odd number of times, 5. So I'll probably go to my calculator, I have a feeling it's 5, and hit 5, math, 5, 3125, or actually I'll go ahead and put in negative 3125 and I get negative 5. So this is 1 over negative 5, or negative 1/5. You could have said negative 1/5 like that, you could have said negative 1/5 like that, or you could have said negative 1/5 like that. The negative either goes on the top, the bottom, or the middle. It means the same thing, negative 1/5. 256 means the 8th root of 256, and then cube it. So in your calculator, hit 8, math, 5, 256. The answer is 2. Now you want 2 to the third, which is 8. It gets much more involved, trust me. Okay, so they're asking about a real world problem. I'm going to come back to that. We're going to get some practice under our belt. All right. Here we are. Okay, whoop, that's the solution. Okay, let's evaluate each expression. Remember, when you're multiplying powers, you add their exponents. So this is a to the 2/7 plus 4/7 power, which is a to the 6/7. I don't see anything wrong with that form. They didn't ask me to write it in radical form. Now this is an interesting one. Remember, if this is over 1, it's the same as 1 over b to the positive 5/6. But there's a problem. We can never leave a radical in the denominator. And because, don't write this, I mean, unless you want to, this means the 6th root of b to the 5th, I'm not allowed to leave this radical in the denominator. So what I'm going to do is multiply the top and bottom by b to the 1/6. Wonder why? Let me show you. Because across the bottom, when I multiply, I'm going to get b to the 5/6 plus 1/6, which is 6/6, which is just b to the 1, and that's exactly what I want. B to the 1 power is a great denominator. I have no fractional exponent in the bottom, or no radical. On the top, I have b to the 1/6. So this is considered the final answer. Again, this was not good because it was the 6th root of b to the 5th. And since I could not eliminate the radical, I had to multiply it by another b to the 1/5 to give me b to the 6/6, which is b to the 1. All right, go ahead and try 4a and 4b. They're very, very similar to what I just did. This is going to be p to the 10 fourths, because I add exponents. Of course, I'm going to make that p to the 5 halves. Over here, this is 1 over r to the 4/5. To make it so I don't have a rational exponent in the denominator, I'm going to multiply by r to the 1/5 on the top and bottom. Why? So that on the bottom I have r to the 5/5, which is r to the 1. On the top, I don't care what I have. I'm allowed to have anything on the top. So on the top, I have r to the 1/5, and on the bottom, I have just r, without any radicals. This is really good. Okay, remember, we can't have radicals in the denominator. So what I do to handle something like a, let me give you a chance to write it, is I multiply by the square root of 3 on the top and bottom. Why? Well, let me show you. Square root of 3 times square root of 3 is now square root of 9, which is just 3. So now we don't have a radical on the bottom, but we do have a radical, some radicals on the top, and I wonder how we're going to handle that. Well, let's first see if we can break up 27. No, it's 3 times 3 times 3. This is interesting right here. Okay, I'm sorry. Took me a second. What we're going to do is write it like this. This is really 27 to the 1/4 times 3 to the 1/2. Now, we can't actually combine them because the bases aren't the same, but do you realize that 27 is a really special number, and they did this on purpose? 27 is 3 to the 3rd power, and hopefully some of us knew that by heart. That is going to be raised to the 1/4 power, because above we have 27 raised to the 1/4 power. Now it's going to be multiplied times 3 to the 1/2 power all over 3. So in the next step, what do we really have? You multiply exponents when you're raising a power to a power. So this is 3 to the 3/4 power times 3 to the 1/2 power. And there again, what do we do when we're multiplying exponents or powers with the same base? You add the exponents. So you wonder, what's 3/4 plus 1/2? Well, that's really 3/4 plus how many fourths? You had to multiply the top and bottom by 2 so that you have the same denominator of 4. So this is like 2/4. So 5/4 is the power on the top. The bottom is 3. And I think that's going to be the simplest answer. No. What they do now is this. This is interesting. Simplify. Okay, what they do now is, since this is the 1 power, and they say when you're dividing like bases, what you do is subtract the powers. Remember, x to the 10th over x to the 8th is x to the 10 minus 8, or x squared power. Yeah, that's what we're doing here. So what is 1? It's really the 4/4 power. So what you're left with is 3 to the 1/4 power. And that is the simplest answer. That is really interesting. So what times itself? 4 times gives us 3. It's obviously not going to be a whole number. All right, let's try something up here. It's actually quite different. Excuse me, quite different. This one's saying, this is like the other lesson, actually. 64 is what? I'm going to break 64 down. I know it's 8 and 8 and 4 and 2 and 2 and 4 and 2 and 2 and 2 and 2. Oh, so in other words, if I have to circle three numbers in order to pull one out. Because it's the third root, I have a 2 and a 2. So I can pull out a 2 and another 2, and I'm going to multiply them. And you know what? That's 4. And actually, that makes sense. If I did the cube root of 64 on my calculator, I would have just gotten 4. And z to the 6th to the third power is just z squared. So it's 4z squared. This honestly could have been in the last lesson, I think. I don't see why this one is actually in this example. You know what? I wonder where this came from. Hold on. Oh, there it is, there it is, there it is. Okay, it's on page 448. I guess it is from this lesson. All right. All right, we're going to try this type now. This one is really, really, really fun. A little on the complex side. All right, what we're going to do here is since I can see that there's going to be an implied radical in the bottom, and I can never have a radical in the bottom, I have to multiply by the conjugate, the top and bottom. So go ahead and write the problem. What we're going to do is multiply the top and bottom by what? Well, the conjugate of the bottom is going to be 3x to the 1/2 and 2. But remember, you change the sign that connects them. So in order to be fair, I multiply the top by the same thing. Now, on the top, I have to FOIL. Well, the bottom too. X to the 1/2 times 3x to the 1/2 is 3. Now that's x to the 2/2, which is just x. Then x to the 1/2 times -2 is -2x to the 1/2. -2 times 3x to the 1/2 is -6x to the 1/2. And last times last gives us +4. Now in the denominator, we get 9x minus 6x to the 1/2 plus 6x to the 1/2. Oh, those cancel, of course. That's why we do conjugates. And then minus 4. So on the top we get 3x, we add like terms, minus 8x to the 1/2 plus 4. And on the bottom we get 9x minus 4. And that is the simplified form. We have no radicals in the bottom or rational exponents. All right, let's try these. Go ahead and pause the tape. Pause the recording. Do all three of these like the ones we just did, and then play the recording. Okay. Oh. Except for number 5A. You might need help. It's a little different than the other one. The thing is about 5A is that in order to get rid of the radical, you have to have, don't write this, the third root of 2 to the third power. Because the 3's will cancel. That's like 2 to the 1/3 power raised to the third power, which is 2 to the 1 power. And then you'd be happy. So what you have to do is multiply the bottom by 3 to 2 squared power. Why? Because right here we only have 1 2. We need 2 more 2's so that we have 3 2's. It's kind of like 3, the third root of x to the third is just x. So again, I multiplied by the cube root of 2 squared so that in the next step I'll have the cube root of 2 to the third power, and then the 3's cancel. So to be fair, I multiply the top by the cube root of 2 squared also. Now the bottom's shaping up. I'm getting the cube root of 2 to the third power, but the top one, again, we have this problem. Different bases, different roots. We can't really combine them, so we're going to rewrite them. 32 is really 2 to the 5th power, and how would we have known that? Well, we play with our calculator. And maybe we just happen to know that, or maybe we broke 32 down to the prime factorization and realized it's 2 times 2 times 2 times 2 times 2. So we're taking 32 and raising it to the 4th power. Then we're taking 2 and raising it to the 2/3 power. Why? Because that's the meaning of this. So what that gives us is 2 to the 20th power times 2 to the 2/3 power, and we have to add those powers. Whoops, let me put it over 2. Finally, the bottom is just 2. Again, taking the cube root and then cubing it gives you 2 to the 3/3 power, which is just 2. Basically, if there's a cube root and then a cube, they cancel. So what we get is 20 plus 2/3. Let's talk about that. I'd have to multiply this by 3 over 3 and get 60 over 3 plus 2 over 3, which is 62 over 3. Something tells me this is wrong. Hold on. I have to pause a second. Found my error already. Okay. Do you realize this is out of control, the size of this exponent? And where I went wrong is 2 to the 5th raised to the 1/4 power. Oh, please forgive me. I'm like, wow, if this works out, this is looking weird. Well, I was right about that. So what we have here is 2 to the 5/4 power, because remember, 5 times 1/4 is 5/4. So now we add the exponents on the top. 5/4 plus 2/3. We need a common denominator. We'll bring them up to 12. So we have to multiply this by 3 over 3 and 4 over 4. So we get 15/12 plus 8/12, which is 23/12. So on the top, we have 2 to the 23/12. On the bottom, we just have 2. So what we do is take 2 to the 23rd 12ths and minus 1, because the exponent on the bottom is implied to be 1. So what that is 2 to the 23rd 12ths minus 12/12, because that's what 1 is, and we get 2 to the 11/12ths power. There's nothing wrong with that answer, but you can change it to the 12th root of 2 to the 11th, and that's what they have listed as my answer. But either one's a really good answer. Okay, 5b. The cube root of 16. 16 is 2 times 8, 2 times 4, 2 times 2. Anytime I can pull out 3 numbers that match because I'm doing the cube root, I do. I pull out a 3, and I can pull out an x. But I'm left with the cube root of a 2 and 1 more x. So that would be my answer. For 5c, I'm going to actually cut it out and do it in the next page because I'm going to have to multiply by the conjugate. And this is a bit of a process. Okay, I'm going to multiply the top and bottom by y to the 1/2 plus 2. So I'm going to distribute and get y plus 2 y to the 1/2 plus 2y to the 1/2 plus 4 over y plus 2 to the 1/2 minus 2 to the 1/2. I hope you see those will cancel. And then we get times minus 4. So we get y plus 4y to the 1/2, because those are like terms that we can add, plus 4 over y minus 4. That's a great answer. I have no radical in the bottom. I have no negative exponents. All right, let's do a couple more. Or are we ready? Woohoo, we're ready for our real life situation. Okay, it says refer to the beginning of the lesson. Suppose a video game costs $390 now. How much would the price increase, and how much would it increase? Not how much will it be, how much will it increase in 6 months with an annual inflation rate of 5.3? So what we're going to do is multiply $390 by 0.053, because remember, when you want to move it to change it to decimal so you can use your calculator that may not have a percent symbol, you move the decimal to the right, to the left 2 times. Now this is going to be the increase for year 1. But the thing is, wait a minute, they give us a formula? Then I'm going to take that number. Oh, I see what's going to be wrong with this. I have to add that number to the 390 to get the new number, and then go ahead and multiply by the 0.03. So that's a lot of computation. The shortcut is this. If you do 1 plus 0.053 times $390, what you're going to get is, this will be the new price, because it will be the 340 plus the increase. And I want to get the new price. Then what I would do is take that new price and multiply by this again the second year. So since I only want to do it for 6 months, that's a half of a year. I raise it to a half power. So I do this in my calculator. And I get $400.20. But it asked how much it's going to increase. I subtract my original $390, and I get $10.20 rounded appropriately. So again, I know I didn't talk about this at length, but I know we have, where I say things like, if you bought something for $390 and there was a 7% tax, you would multiply by 1.07 to find out how much you're going to pay. And then if you had to pay tax again, this would be more like an interest rate where you have an investment and you're making 7% interest. If you just put the number of years here, it's like you continually take that number and continually multiply by 1.07, and it will keep growing for each of those times that you're multiplying. So if this is normally years and it's 6 months, we changed it to 1/2. All right, let's just try this one problem. It was in a test that the county gave, and it was one of those standardized tests, and I want to see if you guys could do it. Go ahead and work it, and then I'll work it. Well, right away I know what 16 to the 1/2 power is. It's just 4, because it's the square root of 16. Then this is x to the 2/3 times 1/2 power, because when you raise a power to a power, you multiply. 9 to the 1/2 is 3, and y to the 4th to the 1/2. So I'm going to multiply those exponents. So I get 4, my 2's cancel, so I get x to the 1/3 over 3y, these cancel, I get 1 and 2, y to the 2nd power. So the answer would be D. Have a great night, everyone.